Hello, welcome to another exciting episode on Coordinate Geometry 1. In this episode, we'll be taking the area of a triangle when the vertices of the triangle is provided. If this is your first time viewing, please make sure you subscribe to the channel on YouTube, like, share, and comment. Now, we are taking, this is our Cartesian plane, we are having the triangle PQR. So if these are the vertices, so this is the first x coordinate, second, third, y coordinate, first, second, third. Now, if we join the vertices to the x-axis, then if you look at this diagram, you'll be dealing with three different trapezium. Let's look at the first one, ABPQ. You look at it, parallel, slant, right? That's the first one. We can also see PBCR as a trapezium. The parallel sides and the vertical one, the height, slant one. Now, the third one is going to be AQRC, the parallel, height, slant. Then if you look at it, all of this together, if I'm looking for the red, which is the triangle, it will be the trapezium A plus trapezium B minus the base will give you the triangle. So let's use that concept of a triangle, of an area of a trapezium to derive the area of this triangle. It's going to be a long method, but bear with me as we take it step by step to arrive at that. Okay, so just like I said, these are the three trapeziums. Trapezium 1 here, plus the second one minus the third one will give us our triangle. So now let's see the side. Don't forget that from here to here is on the x-axis. So the x-axis has the highest point here as x1. So x1 minus the x2. So here will be x1 minus x2. Then if I am picking here BC, highest point will be the x3, the next point will be x1. So I'll be having x3 minus x1. Here is AC. We can see highest point x3, lowest point x2. So x3 minus x2. Right? Good. Let's look at the vertical height here. AQ, that is the height from 0 up to here. You know, the distance here is going to be our y2. Then from here, BP, the x value will be y1. The same value we have for the PB will be here as what? Y1. CR. What is the CR? CR. On the y-axis, the value is y3, right? AQ. What is the AQ? We have AQ, which is still y2. AQ. So we have our y2 there. Then let's see our CR. CR will still be the y3. So these are the dimensions that we need. So let's recall that area of a trapezium. Area trapezium is given by half the sum of the parallel sides times what? The height. So I'm taking this as the first trapezium, trapezium A, 2, 3. So the first one, it will be area 1 equals to half times the sum of the parallel sides. What is the parallel sides? y1 plus y2. So y1 plus y2 times the perpendicular distance, which is x1, x2, right? So that is the first one. We can see it from here. We are picking the sum of the straight sides times the perpendicular what? Distance. Let's expand this one and see what we are going to have. We normally use the absolute value because we are the one who introduced x1, y1. x1 could have been here, y2 could have been here, and y3. So when we get to the end, we introduce the absolute value or the module sign. But let's take this one as we are going. This will multiply, this will give you y1 x1, right? Then minus y1 x2. This will also multiply y2 x1 in the case of this, then minus y2 x2. So that gives us the first area of our trapezium. Then let's pick the second one, area 2, which is also going to be the sum of the straight side 1, 2. y1, y3 times the perpendicular distance, which is x3 minus what? x1. We can expand that one also to have our, let me extend it here, 1 over 2 multiplying y1 times x3 minus y1 times x1 plus y3 times x3, then minus y3 times what? x1. That also gives us the second area of this. So let's go for the third one, which will be area 3. This still be half, right? What is the sum? y2, y3. y2 plus y3 times perpendicular height, which will be our x3 minus what? x2. Just like we expanding, let's expand the terms in the bracket to see what that will look like. So y2 will multiply x3, right? Plus, okay, this is negative, so minus y2 will also multiply x2, y2 x2 plus y3 times this will give you x3, then minus y3 x2. So this will be first area is here, second area is here, the third area is here. We are looking for the area of the triangle. What are we going to do? We add the first two areas, then we subtract the third one to produce the area of the triangle. So let's see how we can put that together. But before then, if I am putting this and this together, as I am adding, the half will be in front, going to be a common factor. So I can factorize the half out. Good. Then if I am adding, I can also see that the ones that will have the same, let's just say like terms, we can easily cancel them out if they have an opposite sign. So let's look at it. I'm having here y1 x1 negative, y1 x1 positive. So this here will cancel this. So in the addition, I will not be making use of this and this because they will cancel. What again? y1, let's go. Okay, I think that's all. We have y3, all the y's are 2 there. There's no x3, so we can keep this one by adding. So from here, right away, I can say that area 1 plus area 2 will be equals to half, as in factorize. Alright, if it is factorized, this is gone, right? So I'll be left with, let me pick positive before negative. So, okay, let's write it in order. Negative y1 x2 plus y2 x1 in the case of this minus y2 x2. That will be added on to here. It will be y1 x3 added on by y3 x3, then we add minus y3 x1. These are addition. Let's see. We have 1, 2, 3, 4. 1, 2, 3, 4. 2 is gone. So we need 1, 2, 3, 4, 5, 6. Instead of 8, we need 6. Now, we need to subtract the area 3. So A1 plus A2 minus A3 will become this and this, which is the half. Half will still be a common factor. So I'll pick the 1, 2 out. Don't forget I mentioned that we'll be using absolute value. But let's keep on using the bracket. In the case of this, I want to combine this already with this and see if I can see a common term to cancel. Let's look at it carefully. y1 x2. Okay, we don't have anything like that. Let's go to y2 x1. y2 x1. No. y2 x2. Okay. Don't forget, if I bring a negative, this negative will affect, where is the negative? This negative we are having here will have effect on all the terms in the bracket. Meaning, if the negative come in front, multiplying this will give you y2 x3 plus y2 x2 minus y3 x3 plus y3 x2. I guess you're with me. The board is not that long so that we can be able to expand it. That's why I'm cutting off some of them. So this is what we are going to have in the case of A3, which we are having a minus. So negative of this and this as a positive, they will cancel. This will cancel this. No, that is not it. This is 2, 3. This is 2, 1. So let's find a different one. We have 2, 3. Okay. 2, 2. This is the one we can cancel. Let me just cancel this and this. What again can be cancelled? We have y1 x2. We don't have it there. Okay, let's look at this. y3 x2. y3, where is it? y3 x3. So that's all. We don't have any other term. y3 x3. y3 x3. Positive, negative. So this will also cancel this. So we will be left with only here, which is y1. We have a y1 x2. Okay, let me bring this one as y3 x2 minus y1 x2. I am bringing these two terms together. Then what term again? We are having x1 here. Do I have any x1? No. What about? Okay, let me bring them down. Since this and this has been taken, let's pick our y2 x1. Where is this? Let's pick our y1 x3. Then pick our negative y3 x1. So since this is coming as a negative, we have our negative y2 x3. What again is left? We are gone. This is gone. These two are cancelled. This one come here. Okay. So let's see how we can group that. Alright, let's see. I am seeing this is x2, x2, x1, x1, x3, x3. So let me group it in that order. 1 out of 2. Then I have my y3, x2 minus y1, x2, we have negative here, positive here, so plus y2, x1 minus, let me introduce a bracket for the pair, minus y3, x1 plus y1, x3 minus y2, x3. This and this also in a bracket. Alright, I think we have summarized everything. I can see x2, x2, x1, x1, x3, x3, which means I can factorize. So if I factorize, 1 over 2 will still be out there. Here I'll be having x2 first, right? Into bracket, y3 minus y1. In this bracket, x1 will be factorized, y2 minus y3, then plus, what will be factorized here? x3, y1 minus what? y2. So this becomes the formula that we are looking for. If you look at it carefully, we are having all the coordinates for x and y. Because I can see, I'll rewrite this with the x1 coming first, x2, then x3. So x1, x2, x3, y1, y2, y3, they are all present here. So our formula as the area will be equal to 1 over 2 absolute value of x1, where is the x1, y2 minus y3, x2, y3 minus y1, x3, y1 minus what? y2. Then bring the absolute value. I mentioned that we use the absolute value because the subtraction is going to be determined by you. You can put the values of p at the top. You can also put p at the end. So definitely in some subtraction you will get a negative value. So you're using the absolute bar, meaning whatever value we get, we are picking the absolute value of that number, not negative. If it's negative, I only pick the number. So this is the formula in finding the area of a triangle when the vertices are provided. Alright, you saw that the diagram, all the points are above the origin. In some cases, whereby the origin will form the vertex, one origin or one vertex will be at the origin. What I mean is that when this is the triangle, you see that one of the vertex is at the origin, meaning that point to be 0, 0. Do you get it? So if we have our, let's say, x1, y1 being 0, I will have my x2, y2, x3, y3 being present. The first one will be 0. So it means that I will look out for this as x1, this as y1, and substitute and see what the equation will be. So let's say at the origin, the area will be equals to half 0 times y2, y3, x2, y3 minus 0, x3, 0 minus what? y2. We know 0 times this will give you 0. So I'll be having 1 over 2 absolute value, x2, y3, this is going to be negative times this. So let me bring the x first. x3, y3, y2. So if I want to rewrite this nicely, this will be your x2, then we can see, if you compare, this is the first and the second. So I can rewrite this as 1, 2. This is the first, the second. So this will also be the 2, the 1. So this gives you another formula if you are asked to find the area when one of the vertices is at the origin. It means the first x times the second y minus the second y times what? The first x. I'm sure the tutorial is a bit long or lengthy, but we are able to follow to this point. Like, share, and comment. Bye-bye.